Brennan, welcome to Validated.
Hey, Austin, thanks for having me.
Hey, thanks for coming on. We got a whole bunch to talk about today. I think this is one of those like classic IBRL episodes where it means a lot of different things to a lot of different people, and one of the most important components of that system is the validator client, right? At the end of the day, for years, it was software that was holding back validator network performance. It's now a lot of the time the physical connectivity layer. It's not necessarily the software side anymore, but there's a huge amount of work that's gone on over the last few years to get these software clients able to handle levels where the public internet becomes a bottleneck. And then a lot of additional work to be done to make the clients make full use of available connectivity if we're moving up to 10 gigabits, 100 gigabits, a terabit of dedicated bandwidth connecting an entire validator cluster like the Solana cluster. So there's a ton to dig in on there. You are one of the core devs on the Solana protocol working at Anza. So I think most people in the Solana ecosystem are familiar with Anza and its kind of history, but I want to start out there for folks who are maybe not coming from the Solana world. What is Anza? How did you get involved in Anza? And walk us through kind of the main validator client you guys build today.
Yeah, absolutely. So I'm Brennan. I'm VP of Core Eng at Anza. I've been here since we did the spin out from Solana Labs. It's been over a year now, and was at Solana Labs for a couple of years before we did that spin out. And so it was the entire core dev protocol team that spun things out at the end of 23 and forked the Solana Labs client and made the Agave client, and have been just absolutely grinding on that ever since. And so that's, a bit of the origin story. A lot of the culture has maintained, it's we were forged in the priority by fire culture and mantra, for better or worse. And I would like to say that we're in a better place now, but there is something to be said about that culture, right? It's definitely a unifying force. It builds resilient devs. Everyone feels like they're pulling in the right direction because they have no other choice. So there's a lot to be said for that. But yes, we're in a much better place now, and can be a little more intentional with the things that we're focusing on and where we really want to drive the client forward. And the really fun part is I think everyone's started to notice that with the V2.1 rollout, because a lot of the highly observable macro metrics that are super important have gotten a lot better. So that's really fun when all like this huge culmination of lots of efforts over the past several months have really come together to push not only the client but the entire network forward.
Yeah, so I want to talk about that, and that's probably a good place to start today, because if you roll back the clock to like early 2022, Solana had a lot of congestion. Solana was going down a lot. The network was a victim of its own success, but at some point people stopped focusing on the success and they started focusing on the downtime. I was at Solana Labs and Solana Foundation during that period of time. You were obviously like involved in these things like very heavily. There was I would say it was as you're talking about fire-driven development. What is the biggest thing on fire that we have to go fix, or what is sort of like the feature set we're sort of jamming in like quick and stake-weighted QoS to sort of address something that was a problem, and maybe as our favorite engineer Trent likes to say, all the wrong decisions were the right decision at the time. And so like talk to me a little bit about like what was going wrong in like 2022 and 2023 to the point where people were like, we need to throw this client away and build FireDancer, to the point where now like the Agave client is keeping pace with FireDancer.
Yeah, let's take a little trip down memory lane and some of those battle scars that we learned and acquired along the way. So, as you mentioned, yeah, we were very much a victim of our own success. So it's the type of problems that we like to have, but they were problems nonetheless. And the largest thing was really just not having the right back pressure handling plus kind of network bandwidth. More hardware always helps. We had a lot of software bugs as well, just not quite utilizing the hardware that we did have properly during that time. And so, what you would see is just queues getting backed up tremendously, and then eventually OOMing and the validator falls over and crashes. And not a great experience for anyone, operators, users, core devs, pretty terrible. And so, a lot of those things in that 2022 timeframe, it took like a variety of different fixes to kind of, get things in a better place. It was having, proper load shedding for like a true distributed denial of service. That's not even what we were really seeing. It was more like popular NFT and token drops, but it's a nice, small scale simulation of a DDoS.
It's also hard to differentiate like what is an attack and what is just a lot of people excited about an NFT drop.
Exactly. And, we were sort of incentivizing bad behaviors during that time as well.
Yeah.
So it was incentivizing the spam and compounding the problem of the success. And so, proper load shedding, moving to quick, upping some of the minimum validator requirements to kind of push things along, getting more efficient with transaction and vote formats and things like that to make better use of the network bandwidth that we did have. It was a lot of different things coming together. So it got us in a better spot that at least the validators weren't falling over, but we were far from perfect still. We had to put priority fees into the protocol so that when we had, this overwhelming congestion, we could at least, shift this to an economics problem rather than just a pure supply-demand asymmetry problem. Because I think that's a much better user experience. Like, at least if my transaction's being dropped, I sort of know why and I know what it would take to land. So priority fees coming in was a big part of it. And then, that still wasn't perfect. I really liked, I think Tim Garcia is maybe the first one I saw use this analogy of the auction house. And priority fees got us an auction house, but we still didn't have a good way of determining who gets into the auction house and are the highest bidders getting in. And so enter, stake-weighted quality of service to allow us to have at least some heuristic to determine where the high-quality flow is coming from and make sure that we have a chance of getting all the highest bidders into the auction house. And so that really sort of brought us to where we are today with a lot of this.
Yeah, so there's a lot of reasons that like software projects get behind the cutting edge and where they need to be. What sort of happened leading up to 2022, to the best of your understanding, that got Solana from a place where things were launched, mainnet was launched, like things were going pretty well? Like, was it just a system where, I think famously, like Solana Labs almost went bankrupt in, fall of 2020, right? Like, I think people forget like how close to death the project was before like it caught some PMF and like that was the moment and off to the races. And was it just sort of like pressure from that like there was never a moment to catch up with after that little bit of PMF happened? Or was there something else from like a engineering structure that needed to get changed internally to like get you guys from 2022 to 2025?
Yeah, so you already quoted our favorite guy Trent, and all the bad decisions were the right decisions. I mean, I think it was largely that, and I think they were the right decisions at the time. You don't ship an architecture, right? You ship a solution. And I had a chance to ask Anatoly about this at the last Core Dev meetup and said, "Hey, were you always a pragmatic engineer? Did you ever kind of live in the ivory tower and say we're going to build the ultimate scalable solution?" And he said, "No, I've always kind of been that way." And I think it's, you want to go create some of that technical debt of tomorrow. If you have that technical debt and it becomes your biggest problem, it means that you've done something right because you're still around and people still want your product and they're still asking for ways for you to iterate and improve it. And so, I think, you had to focus on just getting that thing out, focusing on your niche. Where are you going to be different? Where are you going to kind of extend your edge that gets users excited about using the chain? And once you get some of that niche adoption and critical mass, then, okay, now you can hopefully go solve the problems faster than they sort of take the network down. And a lot of times we had success there. We obviously had some missteps along the way as well where things caught up to us. But the emphasis was always on driving the protocol forward. Having technical debt is a sign that you've done something right. It means that you're building something that people still want to use and are excited to use and want to advance forward. But then it's important to eventually go shovel some of that technical debt so that you're not drowning under it and continue to drive the protocol forward. And so 2022, 2023 was kind of the tipping point where it felt like we were not drowning so much under some of these things. We could be a little more intentional with the development. On where we wanted to drive things forward. Things like getting rid of a lot of these extraneous memory allocations and some of the less glorious work. Like, I think people like to think of a lot of the core devs like embedded in the matrix and doing these insane algorithm changes. And occasionally we get to do that super fun stuff. But a lot of it is just blood, sweat, and tears of yeah, reducing those memory allocations, those syscalls, like hunting them down, getting them out of the code, making things much more clean and efficient, and keeping those pipelines, extremely like well-oiled to just keep things firing.
Yeah, it's kind of one of those like those interesting pieces too, because like Anza does not have more people than when it was part of Solana Labs. Like the core number of core devs has not. I think a lot of people, and we've seen this, and we'll get to a lot of like the improvement and work that's been done, but this is the part of like the engineering world and conversations you really don't hear from people often, is like, how do you take a software project that was like fairly behind where it needed to be and get it to a place where it's like ahead of where it needs to be, without hiring a much more people. Like there's a lot of other networks out there where they're talking about like, oh, we have like 250 people working on core dev engineering, or Apple famously has like over 900 people that just work on the camera for the Pro iPhones. But Anza has about the same number of people as it did working on the code as it did in 2022, and it was part of Solana Labs. So like, I'm kind of curious if there's other things internally that change that have been able to sort of make this happen, or is it just like small effort compounds and you fast forward 3 years and we're in a really different place?
Yeah, I would say it's a little bit of both of those things that sort of help us get over the hump and change the culture. Before Solana Labs, I came from Facebook, which is one of those giant behemoths, tens of thousands of engineers where you can really aggressively attack a lot of different problems with dedicated teams. That's obviously not the case. It wasn't the case at Solana Labs. It's not the case at Anza. We've hired a few people, but yeah, we're more in the dozens range. And so every person is really responsible for such a large amount of code and empowering such a giant portion of the ecosystem, which is also extremely alluring and allows you to attract a lot of top talent. I would say, one of the really important things is just maintaining the culture, that culture of shipping fast, laser focused on what are we including in the next release. How do we, not let perfect be the enemy of, good enough and iterate. That doesn't mean that we can ship junk, but, it does mean that we want to, consistently ship improvements and not focused on 1 year, 2 year, 3 year roadmaps.
Yep.
And so a big part of it is that culture. And because we aren't, growing too fast, we can sort of bring people into that culture and make them live it and ship quickly and be part of this machine. So that's a big part of it. But the other part is the second piece that you mentioned, that it's just a lot of these accumulated gains and really like being unified in where we're pushing those gains. And so I know, at this point it's a bit of a meme, the IBRL thing, but it very much is an umbrella that basically all of our development can fall under. So everyone's pulling in the same direction.
Nice. So I want to pivot a bit and talk about 2.1, where we are today. I mean, you look back like 18 months, maybe even less than 18 months, like skip rate was around 8 or 9%. It's now under 0.5%. Slot times are regularly exceeding 400 milliseconds. They're pretty solidly under that at this point. Transactions per second numbers seem to be going up too. When you have peak demand, that used to be hovering somewhere around 3,000. It feels like it's now touching like 4,600 sometimes nowadays. What's new? Is it sort of a bunch of small bits as you're talking about, or were there some pretty massive rewrites that occurred between the old Solana Labs client and now 2.1 in Agave?
Yeah, a lot of the improvements, driving those numbers going down or up respectively for the macro metrics are the accumulations of lots of small things, but there were a few fun big things that really push things forward as well. I think that the single largest bucket of improvements was around those memory allocations. I think, data movement is the devil, and we've been trying to exercise that devil a lot over the past several months and to, great success with the V2.1 release. That theme is going to continue in V2.2. I think that's, one of the most impactful things that we can do. And so when you look at hitting those 400 millisecond slot times, a lot of it is just a function of how efficient is your pipeline, your transaction pipeline, you're getting the transactions into blocks, and then your shred pipeline, which is getting those kind of micro pieces of the blocks out to the network so they can go replay it and get caught up on state. And the more efficient that pipeline is, the tighter we are to those slot times, the lower the skip rate is, everything sort of follows from there. And so that's really been the largest thing pushing things forward. I think there's also been a big emphasis on retransmit and the scheduler, which are kind of the sexier parts of those pipelines. The scheduler is just such a giant innovation surface, and we've gone through multiple kind of rounds there, from the localized scheduler to the central scheduler to the greedy scheduler, and doing a much better job packing blocks as well.
Yeah, I kind of want to do a little bit of a deep dive on the scheduler, which might be interesting to 50 people, but there's 50 people now who are very excited. Walk me through a little bit of like theory versus operational reality of like different scheduler changes, what you guys have experimented with, and kind of just like how you even think about that problem, because this is like a really like classic computer science 101 problem of like, there's no right way to do this, and there's a lot of wrong ways to do this. And it's kind of like trying to figure out like, what is the least wrong way to do it? But there's like a whole bunch of like philosophical constraints you have to put into the model of how you build a scheduler.
Yeah, absolutely. And so first off, shout out Andrew Fitzgerald. He's the real professor here, but I'm happy to stand out in front and cheerlead a lot of the awesome work that he's done for the scheduler. I'll really walk through those three kind of major scheduler revisions that we've gone through. It started with this is a mouthful, but the thread local multi-iterator, TLMI scheduler, which had more of a localized view per thread when it came to fees and account conflicts, which is fast, at least up front, but not great, because you've got this localized view. And so there can be unfairness where, depending on which thread you fall on, maybe I should have been included, but I didn't because I landed on the one with the high fee pairs.
Right. This was the moments where people were like, I'm putting a priority fee and I'm not getting through, and I'm seeing transactions with lower priority fees that got included.
Yeah, exactly. And so it's a bit of a luck of the draw. It feels unfair. It is unfair. It incentivizes things like spam, which compounds issues that we have. So it's really a bad spot to be. And so that, the solution that we went with was the centralized scheduler, where I've got this centralized view of the locks and the fees, and now I can, much more fairly look at these things holistically and farm work out to the execution threads. And so that was definitely a good step forward. I think this, I would say leaned more towards the academic, like theory side of things that you mentioned, where we built a big prio graph of account collisions, sorted things by priority fee per kind of a unit of work that we needed to do, the CUs, and then scheduled things. And so this is great on paper, but the reality was that building these structures and walking through is kind of expensive when you're running it on actual hardware. And so we saw some inefficiencies in keeping the worker threads loaded up. And so the greedy scheduler is more of the practical compromise, saying, well, we actually know a little something about this workload. It's not just synthetic, fake high TPS load testing stuff. It's actually pretty big, beefy, like swap transactions that are happening. And so I'm better off just creating smaller batches, not building out this whole priority fee graph, more just greedily scheduling things to keep the workers busy. And so that's the gist of what's happening with the greedy scheduler. It's more of that practical twist on the intentions of the central scheduler.
Yeah. And that is in production today?
Yes. So that is, I believe, has been backported to v2.1. It will be default in v2.2, but several people are running that in 2.1 today.
So when I joined Solana Labs in the end of 2020, it was kind of one large code base that was very hard to pick apart. The Firedancer team started from the beginning with this very sort of like componentized version of what the Validator client would look like. My understanding is like over the years, like what is now Agave has evolved to become much more similar. And so that means we see people like playing around with custom schedulers and custom modules and these sorts of things. So there's two pieces I want to talk about. One is like, how do you guys think about like the needs of things like custom schedulers and sort of, as you mentioned, like there are ways to build schedulers that are unfair, but at the same time, like a validator is a dictator when they're building a block. And then the last piece of this is like, how do you go ahead and transform something that used to be kind of one piece of very interconnected code into something where it's more hackable by like other open source developers?
Yeah, overall, when it comes to making the code base more modular and maybe veering more towards a microservice architecture, we're generally supportive of that kind of a thing. I think the Solana red line is we don't shard the database, right. But we can absolutely shard the compute and shard the services. It can make things a little more challenging from a core dev perspective to reason about the system when you have these kind of unique services, maybe running on separate hardware. But we do think that it can lead to a better user experience. if we do it the right way. And so I think it's just an exercise of thinking, what are those units of pieces that you can sort of unentangle from this big monolith that was the Solana Labs client, and safely farm out, and where, what parts are sort of important to open up to the community where they're more interested in innovating on, versus what is more mechanical. And I think a lot of those mechanical pieces fit better into the core validator, or farmed off to specialized hardware. Maybe something like Sig Verify that's very mechanical, is a good candidate for that. Yep. The scheduler is obviously less mechanical. It's extremely important for validator economics. Small little edges can be huge towards accruing higher block rewards and attracting stake and all those kinds of things. And so, we're supportive of making something like that more modular, opening it up. I think, one of the really important things from our perspective is making sure that we don't have this extremely fragile release pipeline with lots of entities that need to hand integrate pieces and things like that. And so how can we have that balance of multiple people or multiple teams involved while still maintaining a release schedule that keeps the client safe and isn't accidentally including invalid transactions, things of that nature.
So you guys have been focused on a lot of, as you said, these sort of like kind of mechanical components inside of the validator client. A lot of the work that's kind of coming down the pike next is like big unlocks to improving performance. They're not isolated necessarily to one validator client or one type of implementation. Alessandro has been tweeting a bunch about Turbine and some of the needs for additional optimizations there. But suddenly that has to interface with the Firedancer client, that has to interface with the Jito client. Even though the Jito client's very similar to the Agave client, there are differences there as well. There have been work that's been talked about changes to Gossip, all these different types of components. So, like, where do you guys draw the line between stuff that's sort of within the domain of Anza to just change and improve and write new software for, and stuff that requires going through, if not a formal community vote on changes, the way economic proposals have to go through like a formal community vote, like protocol implementation details that kind of maybe like Turbine is not technically core protocol, right? Like in theory, if you could get the data into the validator in some other way, there's no actual quote unquote need to use Turbine, but it is effectively core protocol in the sense that if you change something in there that breaks, it breaks it for everyone.
Yeah, and I think we really view these changes in three large buckets. It used to be all one bucket, and at Labs, It was all settled via PR, which was great as a dev. Things move very fast, but we've matured a lot as an ecosystem. We have a lot more stakeholders and a lot more at stake, and so we've had to add a little more friction and a little more process around these things. So we've got the governance bucket. Anytime we're making economics changes, things that are going to impact the profitability of validators and really like easily impact user experience when it comes to economics and things, those need to be governance votes. So that's kind of an easy rule that we have. And then you have more of the protocol changing things. Am I going to break someone else's client or not? Basically, is this changing some data format or some kind of built-in expectation on how I'm assembling network trees or something like that? Those things need to go through the SIMD process, the Solana improvement documents, to make sure that other clients are aligned, agree this is a good direction, come up with timelines for implementing, and when do we actually activate. And so there's lots of things that need to happen behind the scenes to make sure that those types of changes go smoothly. And then there's all the things that are happening inside of our client that you wouldn't notice if it was a black box. And so if it was a black box and you couldn't actually peek into the source code, would you know that kind of the inputs and outputs have changed? And those types of things, we can just unilaterally make better. Using the concrete example that you talked about, Turbine, is an interesting one because it sort of can touch on multiple buckets here. My potentially hot take is that I think Turbine is actually enshrined in consensus, the way we do things. We sort of rely on a certain level of entanglement. Yes. And so, I really view most changes there as a protocol change, or at least, very dicey when it comes to are we still maintaining security. But, a lot of the awesome work that Alessandro has been doing to avoid some of the syscalls into the kernel and some of the like intermediate buffer copies and things like that to go speed it up can entirely just be done unilaterally within the client, which is, a faster process.
Nice. So when we're looking at like pushing the limits of some of these things that are technically in protocol, but they don't require massive engineering changes, how do you think about those? I think the classic example is raising CU limits. In theory, right? Jito had some bugs and was producing very, very large blocks, and like they kind of mostly worked. Like, how do you guys think about, like, I know there was initially we went from 48 to 50 mil, and now there's a 50 to 60 transition, and like, how slowly do we have to ramp up to where Jito was producing, like, I think 250 million CU blocks that like kind of mostly worked? Like, how long does it take to get there?
Yeah, so I'll be happy to report that we have finally activated the feature where we are truly enforcing CU limits on replay, and so we'll be excising a lot of those nasty blocks. But the free validation and free data in the meantime was actually kind of helpful for informing some of these decisions.
100%.
Yeah, and so
wait, sorry, I want to hang on that for a second. Why is it important that the protocol has a hard limit on CU usage that is also the target size for CU blocks? Because I can make an argument that, like, look, if I want to spend 3 times as much money as you do on my validator and mine can handle twice the CUs that yours can handle, like, at some point, isn't this just capitalism and free markets? And like, we should actually be glad that like some validators are doing 100 mil blocks and some maybe are only doing 50.
Yeah, there's absolutely a bit of truth to that. I think the problem is that the rest of the cluster still needs to verify the blocks that are being produced by that leader. And
and replay is still heavy enough that it's a limiting factor. I thought replay was very quick compared to...
Yeah, we have a ton of headroom when it comes to CPU. So it's funny, we parameterized around the entirely wrong thing, right? It's called CUs. It stands for compute units. Compute is where we have the most room. It's the cheapest thing by far, right?
It's all I/O access, right?
Yeah, Kevin Bowers beats the drum on this. So it's all I/O. Network is the most tenuous one where we have the least headroom. And, disk I/O is maybe next in line. Compute, we have plenty of headroom. I think, if we could just magically materialize the data inside all the validators, we could shrink slot times down to about 100 milliseconds and be totally fine today.
Yeah.
So it's really those other two where we have issues and we've been focusing on. And so you bring up the Jito bug and large blocks that were being created. The nice thing is that the common typical workload that we have right now actually plays right into our hands on where the client, where the protocol is strong versus where there are potentially issues. And so what the protocol is really good at is small number of bytes, high complexity transactions. Think, swaps that are trying to look through and tap into lots of different liquidity pools and finding, the most profitable way to perform that swap. That's like the very common transaction and also the thing that we're quite good at today. The fear is that, workloads can change or, certain people can be malicious. And how do we protect from that downside? And so, the visual I get in my head is like, we're driving the car and everything's going right now, but then like we have to turn left and we realize the steering wheel is not exactly attached to the car and we've got major problems.
Yeah.
And so that's where we need to actually enforce these max CU limits, make sure that we're actually charging for things properly across all these sort of macro resources.
Yeah. Are you guys rethinking the nature of CUs at this point? Like, so one of the things of Solana is it was conceived of initially as a DeFi chain and a NASDAQ killer, if we can still use that term. And so it means, as you're saying, it's very good at, I would call them like medium to low complexity operations. But like famously in Solana, it's very hard to reference a lot of accounts, right? Like the transaction size limit is basically governed, correct me if I'm wrong here, but effectively by the MTU size of a shred.
That's right.
And so like, yeah, maybe there's some cool stuff with 00 where we get to go up to jumbo frames and suddenly we're running, 8,500 MTU packets. And so you can fit 7 times as much data in a Solana transaction as you could before. But even 7xing, that's a smaller number than you see in some of like the EVM landscape. So how do you kind of think about that balance between transaction throughput and transaction complexity at like a very low level where you guys are operating on around like a shred is the size of an MTU that can be sent through the internet? Like at some point, like, does that model change? Is this where asynchronous execution comes into play? Yeah.
Yeah, that's a great question. And we're still having passionate debates about the right direction to go here. I mean, I think it's one of the great things that comes with a, vibrant, growing ecosystem of core devs and like high density of smart people in the room that don't always agree with each other. Austin, you would know, better than most about the problems with the public internet, um, and the jitter that can be had on there. It's also nice because it has super high connectivity and it's, oftentimes the only option that people have. But there's one way to minimize or better reason about that complexity is just aligning everything to MTUs. And so you don't have pipeline stalls waiting for multiple packets with our UDP or quick protocols that we're using and trying to buffer and coalesce things and then send it down. Right. It's really nice to be able to just get a packet, do some processing, send it down the pipeline to the next stage and keep the trains moving. And so that's kind of the decision that's been made. We do have the counterpoint and a lot of the early Solana Labs client development that dealt with a higher sort of transaction size and just locally within one data center where you're not dealing with the complexities of the public internet. You could push TPS numbers and things like that and synthetic benchmarks way, way higher. So we know there's benefit to doing that. It also helps with complexity of transactions and a lot of the things that you mentioned. But there's a downside when you move to the public internet. You can stall a lot of those pipelines and things. And so we've been putting some, I'll call them band-aids on to sort of enable some of those things. We have things like ALTs where you can have, a lookup table on chain and effectively kind of inflate your transaction to be larger, but it's more local. It's not heating up that precious network bandwidth. But yeah, it's a little bit messy and it gets IO in the path. And so I'm just kind of, squeezing the balloon and pushing the problems around a little bit. Right now, I mean, a lot of people go sort of outside core protocol to get this done. They rely on Jito bundles, right, to make things happen. And so that's certainly one way that it could be done. That's kind of another school of thought is looking at how can you possibly enshrine, some transaction batches into the protocol to achieve this same sort of phenomenon. But yeah, I mean, I look forward to, more debates in this area and seeing, what delivers the best user experience, because we're happy to take on some dev complexity if it means better user experience in the end.
Yeah, 100%. I want to talk a little bit about going from a 1 or 1.5 validator client network to a 2 or 2.5 client network. There was a huge amount of work Firedancer had to do to catch up with where the Agave client was. And now there's a bunch of work that like Agave is able to do now that they've mostly caught up with where the development is. But we've gone from a world where like PRs and like a little bit of like SIMD work was enough to basically say, okay, now implementation is handed off to one engineering team. Now implementation is handed off to 2 engineering teams, and 2 engineering teams that are not only writing clients in 2 different languages, but have 2 like, not terribly different, but I would say not there's a Venn diagram, let's say, of approaches to solving different problems. And sometimes that overlap is large and sometimes that overlap is smaller. And so how has it been working with another engineering team now? I mean, Ethereum's gone through this growing pain as well. Solana's going through it now, but like walk me through a little bit of that process and sort of how the different engineering cultures are working together and sometimes, making better outcomes and sometimes just having that be a more contentious decision.
Yeah, working with the Jump and Firedancer / Freakin' teams and the Jito team and collaborating on these clients has been, challenging, but also, extremely positive for the network. I think, the great thing is that we're all extremely aligned incentive-wise and high-level direction on where we want to go. And so that helps resolve a lot of the lower level bickering when it's like, hey, we all want the same thing here. There's no question about ulterior motives or incentives when it comes to this. We all want to build awesome clients. We want to make it faster, increase the bandwidth, reduce the latency. So that helps a lot with solving the low level disputes. But there absolutely are growing pains and learning this model. I mean, it starts with the simple stuff of, hey, you can't do that. This is going to, fundamentally break the interaction with the Frankendancer client. We need a SIMD for this. And so just rewiring our brains to think in that mode of, hey, this is a multi-client universe, so we need to, make sure that others are being brought along with us. But then there's also just questions of like exuberance. People are really excited right now. We have, pretty good PMF and a lot of users that are excited about things and a lot of excitement around increasing performance and lots of different ideas on how we should push that forward. But the problem is you can't just come up with an idea and you can't just, implement the code. You need to bring those other client teams along with you and make sure that they have, the staffing and the support and, the right schedules and everything. And so it is a big exercise in coordination. I think we're still figuring that out to a certain extent. But again, it's pretty easy to come together. We have regular meetings. We are competitive with each other because we each want to build the absolute best client. But we're also friendly. We also all see the value of a multi-client universe and the resiliency that can bring to the network and how it actually can enable us to take bigger swings on larger features if we have, downside protection against, possibly a decently staked like minor version on mainnet encountering issues or something like that. And so, again, when you have those high-level incentive alignments, it's a lot easier to come to some technical consensus on the details and what's important on the timeline. I'm not going to use the roadmap word because they're not roadmaps, they're timelines.
No, they're never roadmaps.
Yes, of course.
The problem with a roadmap is people think you should follow it.
Yeah, exactly. Yeah, we don't have that problem. We have a bunch of crazy cats that have awesome ideas.
So I know we're not going to call it a roadmap, but what is next on, let's say, the word cloud of work that the Anza team would like to get done?
Yeah, so there are a few major buckets of performance work that we're focused on to keep IBRLing this year. The single unifying thing is we were absolutely committed to doubling block space this year. So doubling that CU number and making sure that we can pack real user transactions, more of those in to keep median fees low, make it more possible to include transactions even during times of high congestion. So that's the big thing. One of the most important things, I've already kind of beat the drum on the importance of reducing any extraneous memory allocations and keeping those TPU and shred pipelines well-oiled and moving efficiently. That's going to continue being a focus the rest of this year. Another one that I want to mention is retransmit. Mm-hmm. So it's probably the most critical thing that's actually preventing us from getting to doubling block limits this year. And it's really just making sure that after the leader packs that block, how do we get all of that block data out to the rest of the validators so they can go verify the state?
Yep.
We kind of take a hop through the kernel right now, and there's a lot of IOPS, and we put a lot of stress on those highly staked validators that sit at the top of the turbine tree, and they need to fan it out to a lot of nodes beneath them. And it's an interesting design challenge, right? Because the more network hops that you have, the more latency you incur. But the fewer you have, the more fan out you're requiring from those nodes, so the more work they have to do. And so it's a delicate balance. It depends on the number of validators. You start getting into a philosophical debate on what level of decentralization is appropriate and how can you even put a thumb on the scale to try and influence those types of things. But that's a giant focus. And so every time we start going down this path, Trent and Alessandro bring us right back to any slowness in software is a bug that must be squashed, and that's always the easiest answer.
It's true.
Yeah. And so that's a big one. And then, the another bucket that I'll mention is just the kind of silly stuff like, hey, did we pick too expensive of a hash function over here? Do we actually need that protection, or do I have enough entropy in the input? And how many times am I doing this hash map lookup? For the status cache or the block store, or all these kind of individual components that I'm doing several times per transaction or per shred through the pipeline. And so those little improvements there can add up in a major way. So those are really the three major buckets. I don't want to diminish the work of like everyone else. They're working on, incredibly important stuff as well, like, P-token and Pinocchio and things on the contract side as well to make better use of kind of the core validator client. But yeah, those are just a few that I'll call out.
Nice. Yeah, I mean, I've always kind of viewed it as very similar to like the TSMC flywheel of like, just because you made something fast doesn't mean you can't make it faster. And like, if you can cut resource costs like mid-production run, you should do it. And that is how you end up being 7 years ahead of Intel in the fab game. And it feels like Solana is very much running that same playbook.
Yeah, absolutely. And I actually used to work at Intel, and so I'm very familiar with that demise. And also, I used to build storage devices, SSDs, and Intel was really successful in that market in enterprise, and Samsung came in and ate their lunch, right? They made it cheap and they made it fast. Gee, that sounds a little familiar. That may have stuck in my brain and been one of the motivators when I heard the Solana thesis to say, hey, this sounds like a really good idea. And yeah, I think it's it makes a lot of sense to double down on the edge that kind of got you success in the first place. People may think, oh, well, Solana is fast and Solana could keep median fees low, and maybe you need to, go focus on all these other areas, or where are you weakest? And there's a little bit of truth to that, right? We kind of looked at some of the history of outages and said, we really need to take this resilience thing seriously, and we're going to slow down a little bit to go make sure we're extremely robust to DOS attacks and things like that. But now, there's also huge paranoia about getting stagnant and saying, hey, it's fast enough, it's cheap enough.
Yep.
We are like running with our hair on fire all the time, just thinking about other chains, trying to find a different little alignment on the performance versus decentralization spectrum, and try and outcompete us on the thing that got us our initial edge. And so we're like laser focused on that all the time. Drive performance forward. It's a very easy unifying thing. It helps in so many ways that people perhaps don't appreciate.
Yeah, that's awesome. I mean, I will say, I think a core shared experience of a lot of Solana engineers is working for a company that got undercut on performance by another company and lost its market share. Whether that is Qualcomm to Snapdragon, which is also a Samsung thing, or whether it's Intel and Samsung as well. So I think there's a core trauma bonding there that is made for quite performant validator clients.
Yeah, that kind of thing, it sits with you. It stings, and it's you can't chalk it up to marketing or something like that. Performance is so objective. You can run the same benchmarks and you can see it. And so no one likes getting outcompeted on something objective like that.
Cool. Yeah, I hear you. Well, Brennan, thank you for joining us today on Validated and giving us a little bit of a deeper dive into what Anza is doing on IBRL.
Yeah, absolutely. Thanks for having me on, Austin. And, I would encourage everyone to follow along on the Anza blog to kind of stay up with the things that we continue to push. And, we'll continue yapping on Twitter.
Excellent. Thanks.
Thanks.